Pass-through distillation. Part 3. Multiple effect distillation. The first law of thermodynamics tells us that energy cannot be created or destroyed, but may change forms. For example, a heat engine draws heat energy from a hot source, converts a portion of it into useful work, and discharges the rest into a cool heat sink. Distillation operates in the same way, but the useful work generated is not mechanical, but chemical in nature. It is called the work of separation, and it refers to an increase of internal energy. We can observe and measure this work by allowing the products to come to room temperature and recombining them. The work of separation is released as the heat of mixing, causing a temperature increase. In most distillations, this energy is very small, which means that most of the heat added here ends up here, and that provides an opportunity to use it a second time. Double effect distillation uses two evaporators, the first operating at a high temperature and pressure, and the second at a lower temperature and pressure. Plant steam is shown here as the heat source. As it condenses in the steam coils, it gives up its latent heat to the evaporator. Likewise, the vapors generated in the first evaporator give up their latent heat in these heat exchange coils, which serve as condenser with respect to stage 1 and heater for stage 2. The liquid resulting from the condensation is distilled product, which may be combined with a condenser product. At first blush, it appears that every unit of heat coming from the plant steam is generating twice as much product with double effect distillation, that we have cut in half the energy required per unit of product produced. That is a bit of an exaggeration. Remember the work of separation. It is small but not negligible, and it is not affected by the number of effects. A realistic expectation is a 35 to 40% energy saving through the use of double effect distillation, but by adding a third effect, it is quite reasonable to look for a 50% energy saving. One might well ask why all distillation is not carried out with multiple effects. Among the reasons are extra complexity and capital cost. But observe that the additional effects require higher temperatures, making it unsuitable for temperature-sensitive fluids. Let's see how this relates to pass-through distillation. Pass-through distillation excels in handling temperature-sensitive materials at the front end. It can operate at very low temperatures and pressures without the expense of refrigerated condensers, because the vapors are absorbed by an absorption fluid. The absorption fluid travels in a circuit through a distillation process which boils the same material a second time. This stream and this stream are identical in magnitude and composition. In the first evaporator, it came from a fussy, temperature-sensitive fluid or slurry, for which multiple effect distillation was unsuitable. But the second distillation involves clean, thermally stable fluid, to which multiple effect distillation is readily applied. Using three effects, the plant steam required for the absorption fluid regeneration is roughly half that required at the front end. In part 1 of this series, I asked why anyone would ever want to boil anything twice. In part 2, I revealed that decoupling of the evaporator and condenser makes low temperature distillation practical, and promised to show how pass-through distillation can use not twice, but half of the energy of simple distillation. We are now at the end of part 3, and I have demonstrated a reduction from 2 times to 1.5 times that of simple distillation. But I haven't mentioned yet that there is some waste heat inherent in this process that can supply 100% of the thermal load of the main evaporator. With some clever heat exchange measures, we can meet the needs of the main evaporator for absolutely free. The only external heat applied to the system is in the multiple effect absorbent fluid regenerator, which uses half the energy of a simple distillation. In our next video, we will explore how and why this can be done.